All right, hey there. So today we're going to find the points of intersection of a circle and a line. This is the circle, and this is the line we're going to find where the points of intersection are. And just as a reminder, this is the general form of a circle, with the center being HK and the radius being R. So let's go ahead and graph these first. So let's see, x squared plus the quantity y minus 2 quantity squared equals 9. All right, so now let's look at our center and our radius. Let's see, the center, there's no h here, so we'll say that's 0. So we'll say 0, comma, let's see, k, in this case is 2, so 0, 2 is the center. So we'll go up, you know what, 1, 2, there we go, that looks like 2. So that's the point 0, 2, that's the center. Here's the value that will give us our radius. Well, r squared is 9, so that means r is 3. Because we take the square root of this value to give us our radius. So it's 3, so we're going to have to kind of estimate here on the graph. Here's 0, 1, 2, 3, and right there. So here's the center, here's the radius. 3 away from that, we'll go 3 up. So let's see, 2, 3, 4, 5, there's 5, and it'll be negative 3 over here. And then 1, 2, 3 down here, negative 1. Great, and then we'll draw our circle. Ish, all right. All right, so I'll work on my circles, but the point is we got our general graph here. And we're looking for the intersection of that circle and this line, x equals 2. X equals 2 is going to be a vertical line, because no matter what, the x value is 2, so it's going to go up like this. I'll do this in a separate color. All right, so there we have the circle and our line. So we can see it crosses at 2 places. My drawing's not that good, so I'm going to say it might not be exactly on that point, but we should be getting 2 points of intersection here. So let's see what we get. Oh, by the way, I think we showed that the circle is not a function. All right, so let's see, how do we do this? Well, it says x is 2, so let's substitute that in here. But I'm going to have you pause the video, try that out, and see if you can get the points of intersection. All right, so there we go. That was hopefully you paused it. So we'll substitute the 2 in for x. Okay, so now let's see, that's going to be 4. And then I'm actually going to just take it away because I know I'm going to subtract 4, so it's going to be, let's see, y minus 2 squared equals 9 minus 4, which will give me 5. And then we're going to take the square root to get rid of that pesky old square.
Just rewriting it to show that step there.
And then we get y minus 2 equals root 5. And we're going to add 2 over here to get our solution of y. Put it right over here. Y equals 2 plus root 5. Okay, so let's see. Wait a minute, we got a problem. We intersected at 2 points, so we only got one of them. So where's that other one? Well, it actually happens right here, this moment when we take the square root. And that's one of the reasons I showed this, because when you take the square root of a number, this number could actually be the positive or negative of that square root, because when you square it to get back here, this could have been positive or negative. So some ways that you'll see it when you do this kind of work, I'm going to reset this up here. You'll see this as something like this, where it's plus or minus that square root value. So then that gives us the other part of our answer. Y equal, let's see, y minus 2 equals plus or minus root 5. So then this, we'll just add 2, so we get y equals 2 plus or minus root 5. So that's where this other one comes into play. And root 5 ends up being, well, square root of 4 is 2. And that means the square root of 5 is going to be a little bit bigger than 2. So basically what we're left with is 2 plus or minus 2 point, I'm just guessing here, 2.1. I mean, it's about. I mean, I don't have a calculator handy, but it's a small number. It's a bit, sorry, it's a bit bigger than 2. So let's see, 2 plus 2.1 is going to be about 4.1. Well, that kind of makes sense with my poorly drawn circle. I should clarify it's 2 plus that value and then 2 minus 2.1. So this is something about, and by the way, these are approximate, 4.1. That makes sense. And here we have 2 minus 2.1, so that's about negative a tenth, which poorly drawn graph, that kind of makes sense. It's close to the axis there. So there we go. But let's clarify. This isn't the finished product. We need to say what the points are. The x value is 2 in each of them. So here, hang on one second. All right, got cleaned that up a little bit. So our points of intersection are 2, because they're both cross where x is 2, comma, I don't know, about 4.1 and negative 0.1. All right, so those are, and these are approximate. You could go in your calculator, get a number that's closer to the square root of 5. That was just off the top of my head. I could be wrong. I don't have a calculator. But the thinking behind the math is the important part. There we go. So that's how we find the points of intersection of a circle and a line. I'm going to get this board cleaned up, and we're going to do one where we have a horizontal line instead of a vertical line. All right, so here we have a new setup. We're going to look at the intersection of this circle, the quantity x plus 1 squared plus y squared equals 4, and the line y equals 6. So let's go and graph the circle. Actually, before I do that, pause the video, try and graph it yourself, then we'll see how it looks. All right, so here's our circle, and the h and k values are going to be, let's see, negative 1 for the x and 0 for the y. So negative 1 is going to be over here, 0 right here. There we go. I'll call that. We'll call that the point, the center, negative 1. And then in this case, the radius, r squared is 4, which means r is 2. You take the square root of it. So it'll go 2 to the right, 1, 2 up, roughly 2 here. And there, negative 2, no, 3, excuse me. And it'll go down here, negative 2. There we go, then we'll draw it. All right, then we're going to draw the line y equals 6. Line y equals 6 is a horizontal line crossing where y is 6. 1, 2. And you're probably already noticing, Salvum, what gives? They don't cross. And that can happen. Not every line crosses every circle. So there we go. So this line doesn't cross the circle. But something that's important to do is understand not just the picture, but what's happening analytically. Like, how can we show this using this type of scenario? So what I want you to do is try what you can based on the last exercise we did, and see if you can get this picture to show up analytically. So pause the video, and then we'll come back and try it together. All right, there we go. So let's see, y is 6. Let's see, let's go figure this out. Substitute that y, or that 6 in for y.
Okay, there we go. Now this is going to give me 36. And then I'm going to subtract 36.
Now, we should already start to see where this is coming up, why we're going to see this picture not crossing analytically, because we're going to get 4 less 36, and that's going to give us a negative number, negative 32 to be exact. And then let's undo this. Let's just keep going. Take the square root. And this, people, is where we're getting our circle and line not intersecting. Because now we get x plus 1 equals the plus, keep the plus or minus going, plus or minus the square root of negative 32. And this tells us this is a problem because we're taking the square root of a negative number. And our plane here, our xy axes, is only real numbers, but here we're going to get a complex number. So we've stepped out of the real number plane of the xy axes and into the complex plane, which is impossible to show in this two-dimensional set of axes. So this is why we know they don't cross using this analytical method. Visually they don't cross because you graph them, and analytically they don't cross because you can't take the square root of a negative number and get a real number, which is what this is all graphs of. All right, here we go. So find the points of intersection of a circle and a line. Bye.